Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
So let's have examples on finding the resultant of two or more forces. So we will use the uh, first we have to use a scale, engineering scale first, because graphical solution is also possible, and we will do it for two forces that are perpendicular to each other. Then we select a convenient scale, engineering scale, so that the vector or the magnitude representing the magnitude of the force will not drawn out of the area of the paper that you use. So to find the resultant of two forces, we use the graphical method first, and we arrange the components or forces into tip-to-tail approach for situations where the forces are perpendicular to each other, and apply either the parallelogram law and the triangle law to compute the magnitude and direction of the resultant R. So let's have this first problem. Find the resultant of the two forces shown by graphical method using an engineering scale. So here, so we can have a scale of 1 centimeter equals 20 newtons. So that 260 newtons divided by 20 is 13 centimeters, and 13 centimeters will definitely fit on a short size bond paper, or even much more for long size bond paper. And 150 divided by 20 is 7.5 centimeters. So the resultant is obtained by drawing a parallelogram. In this case, it results to a rectangle because the two forces are perpendicular to each other. So we draw a horizontal line going to the left, which measures 13 cm, and a vertical line using your drawing instruments, of course, to definitely erect a line perpendicular to the first, and it measures 7.5 cm. So as mentioned earlier, we have to arrange the forces into tip-to-tail method. So this is the first force represented by 13 cm line, and another line 7.5 centimeters long. Then the vector that, or the line that starts from the tail of the first to the tip of the second, is the resultant. Then all you have to do is measure this line, the length of this line, so using the same scale. So after measuring this line, let us say it results to 15 centimeters. So of course, it's difficult to round off answers or estimate to two decimal places. So it may be 15.1 or 14.9 only. So 15 cm times 20, then it is 300 newtons. The resultant is approximately 300 newtons, and the direction can be estimated also using your protractor. So you have to fit a protractor here because this is by graphical method. So that alpha can be measured using a protractor, or if by analytical method you use tangent function. So alpha is 30.0 degrees by using a protractor. So this is the direct way by graphical method, of course. So R is 300 newtons at theta, so it should be reckoned from the positive x-axis. So if alpha is approximately 30 degrees, then it's the direction of the resultant is 180 minus 30 degrees. So it is 150 degrees. Or you may also answer in this way. You have to, because the resultant is a vector, then you have to indicate using this way the direction, so 30 degrees. So it may also be 300 newtons at theta equals 150 degrees. So there's no more question if it is reckoned from the positive x-axis. So that's the other way. So R is 300 newtons at theta equals 150 degrees, where 150 degrees is 180 minus alpha. So that's it. Then for problem 2, we have to find the resultant, this time by analytical method of two forces shown in the figure. So the two forces are perpendicular to each other. Then remember that if we arrange them into tip-to-tail method, then the resultant can be computed. So r squared by Pythagoras theorem is 9 squared plus 15 squared. Therefore, r is, so from here, this is the resultant by parallelogram law. So r is 17.49 kilonewtons. Then let's compute for this angle here. Let's call that alpha. So it may be cosine of alpha equals 15 over r, or the best way is we will not use r because we compute that. We use the given information. So tangent alpha is opposite over adjacent. So it is 9 over 15. So tangent alpha equals 9 over 15. So alpha equals 30.96 degrees. Therefore, the resultant is R, if 17.49. And if you use this method here, so we have to level the direction from the negative x-axis, and it forms an angle of 40 degrees plus alpha. So 70.96, like that. Or if you represent the resultant by the magnitude and its direction from the positive x-axis counterclockwise positive, then it is 17.49 plus 180 plus 40 plus alpha. So 17.49 kilonewtons at theta equals 250.96, because 250.96 is about 251 degrees. So because we round off values to 4 significant figures, and if you make it 250.96, that would be 5 significant figures. So if you round off value to 4 significant figures, that's 251 degrees.
So problem 3, find the resultant of the two forces shown by the analytical method. So this is the figure, and so we apply parallelogram or triangle law here. So we connect 220 to the 125 Newton force. Then this will be the resultant from the tail of the first to the tip of the last. So this angle is 50 degrees. If you draw horizontal line, that's also 50 degrees. Therefore, the angle here is, because this angle measures 180 minus 50 minus 20, so this is 60 degrees. So therefore, the 220 Newton force makes an angle of 60 degrees with horizontal. So the total angle here is 110 degrees. So that's the parallelogram, that's 110. This is also 110 degrees. And this must be 70 degrees from property of parallelogram. So this is the resultant force. We can solve R using this triangle and using cosine law. So R square equals 125 square plus 220 square minus 2 times 125 times 220 cosine of 110 degrees using your calculator there. So R is 287.8 newtons. Then let's determine this angle here, beta. Let's compute beta. It is expected to be acute. So by sine law, 220 as to sine beta equals R 287.8 as to sine 110. So beta therefore is equal to 45.92 degrees. Then let's call this angle alpha. Let's find out if alpha is acute. So alpha is 180 minus 50 minus beta. So alpha again is 180 degrees minus 50 minus beta. So alpha is 84.08 degrees, so it is an acute angle. Therefore, in standard form, from the positive x-axis counterclockwise to the line of action of R, that's 360 minus 84.08 degrees. So therefore, the resultant is reported in this manner: magnitude and direction. So R is 287.8 at 360 minus 84.08 degrees, or in this report, as long as we indicate it from the positive x-axis clockwise, so 84.08 degrees, as long as it is shown here. The other way is R is 287.8 at theta equals 360 minus 84.08 degrees in standard form, counterclockwise, so to 75.9 degrees. And the last way is R equals 287.8 newtons at theta equals negative 84.08 degrees, because clockwise from the positive x-axis is negative. So that's the proper way. Any one of these is the way of expressing the resultant, not only the magnitude but also its direction. Then for problem 17, this is revised. The u and v axis must be perpendicular to each other. So resolve the 240 Newton force into u and v components by vector approach works. This vector approach works only if u and v are perpendicular, matches with the parallelogram law. So originally, the u and v axis in problem 17, if you watch the video, very long video of course, this is the last problem, were not perpendicular to each other. So I revised it to be perpendicular to each other, because this approach works only when we resolve the force into components that are mutually perpendicular. If they are not perpendicular, then the analysis would be different. Similar to problems 15 perhaps. So notice that u and v axis now are perpendicular to each other, so 30 degrees, 60 degrees, so the angle between them would be 90 to form a straight line angle. So this is 40 degrees, therefore the resultant, or the force of 240 Newton magnitude, makes an angle with a positive x-axis of 90 degrees plus 40, so 130 degrees. In vector form, this 240 newtons is 240 cosine of 130 degrees. This is 130 degrees, 90 plus 40, I plus j sine of 130 degrees. So 240 cosine of 130 degrees I plus sine of 130 degrees j in vector form. So F is negative 154.27 I plus 183.85 j. The u direction in vector form is, unit vector form is cosine of 60 degrees I plus sine of 60 degrees j. So the unit vector u is cosine 60 degrees I plus sine 60 degrees j, while in decimal 0.5 I plus square root of 3 over 2j. While the unit vector for v, it makes an angle with the positive x-axis of 150 degrees, because this is 30, so 180 minus 30 from the positive x-axis counterclockwise, so that's 150 degrees. So the unit vector of v is, so fu therefore is the dot product of f and lambda u. So it is the component of the force in the direction of u. So we obtain that product because the result is supposedly f dot lambda u is magnitude of f magnitude of u, which is 1, times cosine of the angle between them. So that's F cosine of the angle between the two vectors 240 Newton and the unit vector u. So that is the u component of F. Again, this is F dot lambda of u. The result by that product is magnitude of F, magnitude of u, which is 1. So F times 1 is just F, cosine of the angle between them. Therefore, F cosine of the angle between them is the component of Fu, which is two, the component of 240 Newton force in the direction of u, which is the component of the force in the direction of u, which is the requirement here. From the definition of that product, it is just negative 154.27 times zero point 0.5 plus 183.35 times square root of 3 over 2. And that is equal to 82.08 Newton. So that's the answer. Then lambda V is cosine 150 degrees I plus sine 150 degrees J. So that would be equal to negative 154.27 I plus 183.35 J. This is F dot lambda of V. The result is F, magnitude of F, times 1 times cosine of the angle between the force 240 newtons and V. So therefore, it is F cosine of the angle between them. So that's the V component of the force. So FV is negative 154.27 cosine of 150 plus 183.35 times sine 150. So therefore, it is equal to 225.53 newtons. So these are the components of the 240 Newton force in the direction of U and in the direction of V. And this problem or this approach is applicable only when we resolve the force into components into two axes that are mutually perpendicular. So this approach works when we resolve the force into two axes that are perpendicular. If they are not perpendicular, then we analyze it in a different manner. So we apply the principle on triangle or parallelogram law for that case. So that's it. That's the correction.
Let's have problem 3. Find the resultant of the two forces shown by the analytical method. So these are the two forces. Let's have tip to tail method and let's use parallelogram law here. So these are the given information. So first we draw the 125 Newton force and it is 50 degrees from the horizontal as shown. Then we connect the second force of 220 newtons. So take note that the first force makes an angle of 50 degrees with the horizontal. Then if we draw a line from this tip of the first or tail of the second, then the angle, the measure of this angle is also 50 degrees. Then the 220 Newton force makes an angle with horizontal of 180 minus 50 minus 70. So that's 60 degrees. So this is 60 degrees. Therefore, this 220 Newton force makes an angle of 60 degrees with horizontal. So that's 60 degrees. Then we draw parallel lines to form a parallelogram. So the measure of this angle is 120 degrees. How is 120 degrees computed? Or this is 110 degrees because remember adjacent interior angles of a parallelogram is the sum of the adjacent angles of a parallelogram is 180 degrees, or adjacent angles are supplementary, so this is 110 degrees, and this is the resultant. So that's also opposite angles are equal, so that measures 110 degrees. So this is also 70 degrees. So this is the resultant. By cosine law, r square equals 125 square plus 220 square minus 2 times 125, 220 cosine of 110 degrees. So using your calculator, this is from this triangle here. This angle is 110 degrees, 50 plus 60. This is the side opposite to 110. So by cosine law, it is square of the first side plus square of the second side minus twice the product of the first and the second sides times the cosine of the angle, which is 110. So R is 287.8 newtons. Then by sine law, let's solve for this angle beta here. So 220 as to sine beta equals 287.8 as to sine 110 degrees. So solving for beta using your calculator, it is arc sine of 220 times sine 110 divided by 287.8. Again, beta is arc sine of quantity 220 sine 110 divided by 287.8. So beta is 45.82 degrees. Therefore, 50 plus 45.892 is 95.92. It exceeds 90 degrees. So we solve for this alpha because this is acute. So to solve for alpha, it is 180 minus 50 minus beta. So 180 minus 50 degrees minus 45.92 degrees is equal to 84.08 degrees. So the resultant can now be represented by its magnitude to 87.8 newtons and its direction, which is from the horizontal axis 84.08 degrees. So 17.49 kilonewtons at this angle here, direction 84.08 degrees. Another way is R is 17.49 kilonewtons at theta equals 360 because it is in the fourth quadrant. 360 minus 84.08 degrees. So that would be theta equals to 75.9 degrees. Again, 360 degrees minus 84.08 to four significant figures to 75.9 degrees. Another way is R is 17.49 kilonewtons at theta equals negative 84.08 degrees. Negative because it is clockwise from the positive x-axis. So that's it. You may represent your answer in any one of these three representations. Next, problem 4. The trucks A and B are pulling another truck C as shown below. If truck A is pulling with a force of 12 kilonewtons and truck B is pulling with a force of 8.5 kilonewtons, determine the resultant force on truck C. So this is the figure. Then we first compute the angle that the truck A makes with this vertical here. So we form a right triangle, horizontal and vertical components. This is tension A, the hypotenuse. Then this is theta A. 20, 22 plus 9 is 31. Then theta A, tangent theta A is 20 over 31. So theta A is arctan of 20 over 31, and that is equal to 32.83 degrees. Then for this right triangle here, for track B, 8.5 kilonewtons the tension. This is also 20, and we have 9, and call that theta B. So this is a right triangle, so tangent of theta B is 20 over 9. So theta B is arctan of 20 over 9. So theta B is 65.77 degrees. Then the angle between these two tensions is equal to theta B 65.77 degrees minus 32.83 degrees. And that angle is this angle here. So this is the two tension forces, and the measure of this angle is again 65.77 minus 32.83 is equal to that's theta A, this is theta B, so this angle is theta B minus theta A. 65.77 minus theta A, 32.83, so the result is 32.94 degrees. So again, this angle here, the bigger angle, which is an obtuse angle, is 180 minus 32.94. That's the resultant. So let's consider this triangle here. Let's solve alpha. Alpha is 180 minus 32.94. So therefore, alpha is equal to 147.06 degrees. Then by cosine law, r square equals 12 square plus 8.5 square minus 2 times 12 times 8.5 cosine of alpha, which is 147.06 degrees. So solving for the magnitude of R using your calculator there, 119.68 kilonewtons. Then for the direction, we need to compute this angle here. Let's call that angle beta, and we compute that by sine law. So opposite is 8.5. This is 8.5, so that's also 8.5 as to sine beta equals R 19.68 as to sine of alpha, which is 147.06. So the angle that the resultant makes with this horizontal here is indicated as theta r. So 8.5 as sine of beta equals r 19.68 as to sine of alpha, which is 147.06. So beta is arctan of the quantity 8.5 sine 147.06 divided by 19.68. So beta is 13.58 degrees. Therefore, theta r is equal to 90 degrees. So from the vertical, 90 degrees minus this angle, which is theta a, then minus beta, which is 13.58. So theta r is 90 degrees minus beta, 13.58 minus theta a from the vertical theta a, that's 32.83. So theta r is 43.59 degrees to 4 significant figures. So finally, we express the answer as 19.68 kilonewtons in this method here, which makes an angle with the horizontal of 43.59 degrees from the left, from the horizontal. So that's the direction of R. So that's the answer. Problem 5. Find the resultant of the three forces shown by the parallelogram law. There are three forces, so you may first compute the resultant between the 80 and the 120 Newton force, or it may be 120 and the 150 Newton force. So it's up to you. Or it may be 80 and 150 Newton first. So this is the solution. We first compute the resultant between the 80 and the 120 Newton force. So the angle here is 180 minus 50 minus 42. So this is the parallelogram. That's the resultant, of course. Let's call the resultant between the 80 and 120 Newton force as R12. Then after we compute R12, we combine it with this third force, 150 Newton force, to form another parallelogram to compute the final resultant. So again, this angle is 180 minus 50 minus 42, so that's 88 degrees. And therefore, this adjacent interior angle here is 180 minus 88, so that's 92 degrees. So in short, this is automatic the sum of 50 and 92, because this angle is 180 minus 50 minus 40 minus 42, 88, and this is 180 minus 88, so that's also 92. So by cosine law, R12, R12 square is equal to 120 square plus 80 square minus 2 times 120 times 80 cosine of 92. So 120 square plus 80 square minus 2 times 120, 80 cosine of 92. So using your calculator, R sub 12 is equal to 146.5 newtons. Then of course, we need also to compute an angle, let us say uh, the angle beta here between the resultant and the 120 Newton force. So by sine law, this is 80 as to sine beta equals 146.5 as to sine 92. 146.5 as to sine of 92. So beta is arcsine of quantity 80 sine 92 over 146.5, and that would be 33.08 degrees. So the angle between the resultant R12 and 150 Newton force, therefore this angle here, the measure of this angle is 20 plus 42 plus 33.08, and this is the parallelogram formed on the vectors of these two forces, and that's the resultant. So we need to compute alpha. Alpha is 180 minus 33.08 minus 42 minus 20. So 180 degrees minus 33.08 degrees minus 42 minus 20 degrees. So alpha equals 84.92 degrees. Then, knowing alpha, we can now compute the magnitude of the resultant force from this triangle here by cosine law again. So r square is equal to 146.5 square plus 150 square minus 2 times 146.5 150 cosine of alpha, which is 84.92 degrees. So using your calculator, r is 200.2 newtons. Then for each direction, we have to uh, compute uh, another angle. Let's say this angle here. That's also alpha. So this is theta. From the horizontal is theta plus 20 degrees, the whole angle here. From the 150 Newton force to the direction of r is theta, because theta is the designation of the direction of r from the positive x-axis, plus 20 degrees. So by sine law, opposite is r12 or 146.5 as to sine of theta plus 20 degrees, then equals 200.2 or r as to sine of alpha, which is 84.92 degrees. So from this triangle. So again, 146.5 as to sine of theta plus 20 degrees is equal to r 146.5 as to sine of alpha 84.92. So theta therefore is quantity arcsine of quantity 146.5 sine 84.92 over 200.2 minus 20 degrees. So theta is 26.79 degrees. Therefore, our final answer is r 200.2 at theta equals 26.79 degrees. So it is understood that the direction is from the positive x-axis counterclockwise, because that's positive. Next technique is by resolving a force into its components. So let's have here the 2D case. First, later in the subsequent uh, videos, we will consider 3D situation. So the process of expressing a force into its components is called force resolution. So problem 6, for the 300 Newton force shown below, resolve it into x and y components, b, u, and v components. So we have here a force. There are so many ways to resolve this force into its u and v components. For the meantime, let's just have the parallelogram law, or let's form triangles here. So let's, from the tip of the force, we draw lines parallel to the u and the v axis to form a parallelogram. So from this 300 Newton force, which makes 55 degrees, with respect to the x and y components, so we draw horizontal and vertical lines because x and y are perpendicular to each other, and we have horizontal and vertical lines. So this is fx. Fx is equal to 300, the hypotenuse, times cosine of 55 degrees. So fx is 300 cosine 55. Fx is 172.1 newtons, and that is rightward. Fy is upward, and from this right triangle, it is hypotenuse opposite of 55, so hypotenuse sine of 55. So Fy is 300 sine of 55 degrees. So Fy is equal to 245.7 newtons upward. Then with respect to the U and V axis, same principle. We draw lines parallel to the U and the V axis. So take note that this angle is 40 degrees because U and V axis are also perpendicular to each other. So the parallelogram reduces to a rectangle. So the measure of this angle that the 300 Newton force makes with the U axis is 40 degrees, and 40 degrees is 55 degrees minus 15 degrees from the figure. So this is the U component of the force, which is hypotenuse 300 cosine of 40, and the FV component is hypotenuse 300 sine of 40. So FU is 229.8 newtons at, of course, 15 degrees. Then FV, that's FV, it's 300 sine of 40 degrees, FV. Then it is equal to 192.8 newtons at theta equals 90 plus 15, so 105 degrees, or 75 degrees from the negative x-axis, or 105. You may also answer 192.8 at theta equals 105 degrees. Then 75 is of course 180 minus 105, so 75. That's also the other way.